Okay, last lesson we talked about simplifying rational expressions. This lesson we're going to be talking about dividing polynomials, and I want you to see how those two are connected. Let's say you have a fraction like 20 over 25. There are two different things that we can do with that. We can reduce it, and we can say that it's going to be 4/5, or we can divide it, and we could do 20 divided by 25 and get 0.8. So last lesson was like this. This is like simplifying rational expressions. And this lesson is dividing polynomials. So notice in both cases we are dividing because the fraction bar is just a division sign, but our answers look a little different. They have the same value, but they look just a little bit differently. So I want you to see that connection. Okay, I'm going to skip the concept summary for right now because notice it says it's dividing a polynomial by a polynomial, and our first two examples are not polynomials. So the process is a little bit different. So we'll come back to that concept summary. So here, if we have 15x minus 6 and we're going to divide it by 3x, so we could rewrite it like this, and then we're dividing this part by 3x and this part by 3x. So we're not going to do any sort of long division format right here, not yet anyway. So let's do that. So if we do 15x divided by 3x, we get a 5. And if we do a -6 divided by 3x, we get a -2 over x. I know that looks a little bit weird, but it's right. So now let's do this next one. So we're going to divide every term by the monomial. And let's just go ahead and simplify now. So the first one, we've got a 3x. The second term, we're going to end up with a -2. And then the third, 15x over 3x squared, we end up with a +5 over x. And we're done. All right, so now we're going to start doing polynomials divided by polynomials. So let's go ahead and look at this top concept summary now. So here is what you've got to do. So really the one that I want you guys to pay special attention to is step 1. You've got to arrange the terms of the dividend and the divisor in standard form. Remember, that goes from the highest degree term to the lowest degree term. And then if a term is missing from the dividend, then you're going to add the term with a coefficient of 0. So if it's missing from the dividend, then we're going to add some terms. So I'll talk about what that means specifically when we get to it, but I want to just highlight that right now. The next steps, you can definitely read those, but it's exactly the same steps that you used when you did long division with numbers. So you'll see that it looks really, really similar. So let's go ahead and do one. Okay, so I'm going to rewrite the 3d squared minus 4d plus 13, and we're going to do divided by d plus 3. Now, let's just make sure and check that this is in standard form. So 3d squared, we've got a squared term, then we've got a d to the first, and then essentially on that 13, we could have a d to the 0. So we're in good shape. We don't have to add any terms. We don't have to move anything around or anything like that. So we can just start dividing. So here's what we're going to do. We're going to ask ourselves, how many times does d go into 3d squared? So you're just going to look at the first terms that we're dealing with. So how many times does d go into 3d squared? It goes in 3d. So d times 3d is equal to 3d squared. So notice I said it was 3d. I want you to look at each of these terms. I'm going to go ahead and create some columns here. This column right here is the d squared column. This column right here is the d column, and this is the constant column. So notice when we said that d times 3d was equal to 3d squared, let's put that in the d column. So 3d, now we're going to multiply. So 3d times 3, that gives us a 9d, and it's a positive. and then 3d times d is 3d squared. Okay, just like long division with numbers, we're going to subtract. I always circle my subtraction here so I remember that I'm not just subtracting these guys, but I'm also subtracting that 4d and the 9d squared, or the 9d. So we've got negative 4d minus 9d. So that's going to be a negative 13d. And we bring down our 13. Now, how many times does d go into negative 13d? And you hopefully are saying negative 13 times. So we're going to put our negative 13 in that constant column. And then we multiply. So negative 13 times 3. So that's a negative 39. And negative 13 times d is a negative 13d. Now we subtract. These go away. 13 minus a negative 39 is positive 52. And this is our remainder. So again, just like you did with long division, we're not going to, put decimals and carry them out. We're actually going to write a remainder. So we're going to do, since it's a positive 52, we're going to say plus 52 over the divisor, so d plus 3. Okay, so there is our answer to our division question. Okay, let's go on to the next one. So we've got 20t squared minus 5t plus 4. Let's go ahead and check that. We've got a t squared, a t to the first, and then essentially a t to the 0. So we're in good shape. Everything's there, and nothing needs to be rearranged. Then we've got 4t squared minus t. So now we're going to ask ourselves, how many times does 4t squared go into 20t squared? And it goes in 5 times, right? So 5, we need to put the 5 in the constant column. So we're going to put a 5 right here. Now we're going to multiply. 5 times, now notice there's nothing, it's not 5 times negative t needs to go here, negative 5t. So make sure you're keeping your columns constant. And then 5 times 4t squared is 20t squared. Now we can subtract all the way across, and these both cancel out, and then we can bring down our 4. At that point, we don't have anything anywhere else to put any numbers up here, so this is our remainder. So it's a positive 4 over the divisor, 4t squared minus t. And we've got our quotient. Okay, moving on. Now let's do a geometry application. It says the width of a rectangle is 3z minus 1. So let's go ahead and do this, 3z minus 1. The area of the rectangle is 18z cubed minus 8z plus 2. And then what is the expression for the length of the rectangle? So hopefully you're thinking, well, you divide the area by the width to find the length. So let's do that. So 18z cubed. Now notice this. It goes from a cubed term to a z to the first. So we're missing that squared term when we have to have it. Otherwise it's going to be a mess when you try to divide. So what we're going to do is we're going to add a 0, and I think I changed to x's when it should be z's. Let me fix that. A 0 z squared, and then we can go ahead and finish it. Negative 8 z, and then plus 2. And then on the outside, we can do our 3z minus 1. Okay, now let's go ahead and start dividing. So we're going to ask ourselves, how many times does 3z go into 18z cubed? And hopefully you're saying 6z squared. So we've got to put it in our squared column, so 6z squared. And now multiply. We end up with a minus 6z squared here and an 18z cubed. Now we subtract. This goes away, And now this becomes, it's a 0 minus a negative, so it's going to be a positive 6z squared. Bring down our negative 8z. Now, how many times does 3z go into 6z squared? Is twice, or 2z times. And now multiply. So 2z times negative 1 is negative 2z. 2z times 3z, 6z squared. This goes away, and we end up with a negative 6z. Yeah, negative 6z. And then we're going to bring down our plus 2. Now, how many times does 3z go into negative 6z? Is negative 2 times. And multiply across, and we end up with negative 2 times negative 1 is positive 2. Negative 2 times 3 is negative 6z, and we have no remainder. So here is our length. Okay, so just remember, if you're missing a term, you add it with a coefficient of 0. All right, now let's look at this one. So let's go ahead and check these first. Are we missing any terms? We've got a square term, we've got an x to the first, and then we've got essentially an x to the 0. But it's not in standard form, so we've got to move it around. So let's put it in standard form, and then we can go ahead and divide on the outside. So that one also needs to be put in standard form. So we're going to put a 2x minus 3. Okay, so how many times does 2x go into 4x squared? Goes in 2x times. Notice I'm keeping my columns consistent. So 2x times negative 3 is negative 6x. 2x times 2x is 4x squared. Subtract across, we end up with a negative 4x minus 1. 2x into negative 4x is negative 2. Negative 2 times negative 3 is positive 6. 2 times 2 is 4. Negative 2 times 2 is negative 4, and then subtract across, we get a negative 7. So now our remainder, now it's negative, so it's a minus 7 over the divisor, so 2x minus 3. And we've got our quotient. Okay, so what I did is I put a couple more examples at the bottom that are from the practice, from the book. So I'm going to go ahead and do these. I would highly suggest you pausing the video and trying to do them on your own and then coming back. There are a couple of these that are kind of tricky, so don't get overwhelmed by it. Know that some of these are a little hard. So, okay, so let's go ahead and do this one. So we've got negative 16c squared plus 28c plus 12. Let's go ahead and check it. We've got a c squared, a c, and a c to the 0 divided by 4c squared minus 7c minus 3. 4c into negative 16c, it goes in negative 4 times, and it's a constant, so I'm going to put it in the constant column. So then let's multiply. Negative 4 times negative 3 is positive 12. Negative 4 times negative 7c is positive 28c. Negative 4 times 4, negative 16c squared. And we've already finished because there's a remainder of 0. So that one wasn't too bad. But it looked a little hard at the beginning because it's a trinomial divided by a trinomial. Okay, so let's do 21. This one's the one that's kind of tricky. So let's first just check. We've got a fourth term, a third term, and we're missing a t squared. So we've got to add it. So let's go ahead and do that. So we've got 2t. I have enough room. I'm going to go over to the back here where I have some more room. So we're going to have 2t to the fourth minus 2t cubed plus, and we've got to add that term, 0t squared plus 3t minus 1. And then on the outside, we've got the 2t cubed plus 1. I kind of prefer, it says on that concept summary that you just need to make sure that the dividend isn't missing any terms, but I kind of like to make sure the divisor isn't either. So I'm going to actually rewrite this as 2t cubed, and notice it's missing a square and a t to the first term. So I'm going to say plus 0t squared plus 0t, and then plus 1. Okay, looks kind of messy and super long, but it'll be okay. So now let's just go through our process. So 2t cubed goes into 2t to the fourth. It goes in t times. So we're going to go all the way over to our t column and put it right above the 3t. Now let's multiply. So t times 1 gives us t. T times 0t gives us 0t. T times 0t squared gives us 0t cubed. And then t times 2t cubed gives us 2t to the fourth. Okay, subtract all the way across. This goes away. Then we bring down a negative 2t cubed plus 0t, I should have put a squared there, squared, and 3t minus t, and that gives us a plus 2t. And now let's bring down our negative 1. Okay, now how many times does 2t cubed go into negative 2t cubed? It's negative 1. So then multiply across. We've got a negative 1. Then negative 1 times 0t is 0t. Negative 1 times 0t squared is 0t squared. Negative 1 times 2t cubed is negative 2t cubed. Now we subtract all the way across. That goes away, and then we end up with a 2t, and then just a 2t, because the negative 1 minus negative 1 is 0. So there's our remainder. It's positive, so we're going to say plus 2t over the, I'm just going to put the original divisor now, so 2t cubed plus 1. And I think that's probably the messiest one here. So if you're good with that, then you're in really good shape. Okay, let's go on to the next one. So are we missing any terms? We've got a cubed term, we've got a squared term, we've got a z to the first. The only problem is they're not in order. So let's put them in order. So negative 2z cubed plus z squared minus z plus 1. And then we're going to divide it by z plus 1. So now let's go ahead and start the process. How many times does z go into negative 2z cubed? And it goes in negative 2z squared times. Notice I'm putting the squareds in one column together. Now let's multiply. So negative 2z squared times 1. So that's going to be a negative 2z squared. Negative 2z squared times z is negative 2z to the third. That goes away because we're subtracting. And then we end up with 3z squared. Bring down our minus z. Now how many times does z go into 3z squared? Is positive 3z. So multiply. 3z times 1 is 3z. Positive. 3z times z is 3z squared. We're going to subtract across. We end up with a negative 4z. Bring down our plus 1. Now, how many times does z go into negative 4z? So negative 4 times. I have to make my whole thing smaller. I'm sure you guys wish you could do that too, right? Okay, now we multiply. Negative 4 times 1, so that's negative 4. Negative 4 times z is negative 4z. Subtract, that goes away. We end up with a positive 5, and so that's our remainder. So plus 5 over the dividend, or excuse me, the divisor, and we have z plus 1, and there is our quotient. All right, finally, last one, 6m cubed. We're missing an m squared, so plus 0m squared plus 3m plus 70 divided by m plus 4. Okay, how many times does m go into 6m cubed? Goes in 6m squared times. Multiply and get 24m squared, and that's positive 6m cubed. Subtract negative 24m squared, bring down our plus 3m. Now how many times does m go into negative 24m squared? Negative 24m times. Multiply across, we get a negative 96m. and negative 24m squared. Subtract, get 99m, bring down our plus 70. Now, how many times does m go into 99m? Is 99 times. Multiply across, get a positive 396 and 99m here. Okay, gotta make it smaller again. These are kind of long, huh? Okay, now subtract. The 99 goes away. We end up with a negative 326, and that's our remainder. So minus 326 over the original divisor, m plus 4, and we are finished. Big key here is not to forget that you're subtracting all the way across. The most common errors students make is just small are just small arithmetic errors. So be really careful with your positives and negatives and with your adding and subtracting. All right, last view of the notes. And I will see you guys tomorrow.